Chapter 6, Section 4. So it talks about areas in the XY plane. Right? We talk about previous sections, we talk about like this. We have functions. So the blue line represents the graph of function f. This graph. Oh, to plug this in. Okay. So we talk about the area under the function, right? So the shaded region, the area, we could use the integration. We integrate f of x from A to B, right? Remember that. So f is a derivative of capital letter F. So we anti-differentiate, get f of x. Then we evaluate at B. Then we subtract the evaluation at A. That's how we get the area under a function or under a curve. So if we switch the integration sign, they introduce a negative sign. So from A to B, if we have negative sign, well, this is a -1, right? We can pull the -1 up from the integration. So this is showing if we have the area under x-axis. So if the area is under x-axis, so what do? We take absolute value of that, the function. So we negate the negative. By negative, negative become positive. So we negate negative. So once we put the negation sign negative, it becomes positive. So when the area is to be negative, all it means is under x-axis, because there's no negative area, right? So when we do the pure mathematical calculation, sometimes we do get a negative. The only means is under x-axis. So let's see this picture. So how do we find the area of all this shaded region? We say A is under, so we need to put negative sign in front of the differentiation. So from A to C, f of x dx. Or B is above, so it's a normal. So from C to D, f of x dx. C is under, so we negate. So from D to E, we do negative, negative. So if it's under x-axis, we put a negative sign. Then plus from E to B, f of x dx. But if it's above x-axis, we take a positive. If it's below x-axis, we negate the negative, so it becomes positive. Let's see this example. So this example, we have this function, x squared minus x, and we want to find the area from 0 to 2. So we need to split it into two integrals, right? So from 0 to 1, we see the area is under x-axis. We'll put a negative sign up front. And the integrand is a function f of x, so dx. Then plus from 1 to 2, which is above x-axis. So we take a positive. So the process will be the same. We anti-differentiate x squared minus x. So this is also x squared minus x. So we get x cubed divided by 3, right? So anti-differentiate x squared, get x raised by 3 divided by 3 minus x squared divided by 2. Then we evaluate from 0 to 1. Then plus this one, it will be same, x cubed divided by 3 minus x squared divided by 2. We evaluate this from 1 to 2. Okay, so from 1, we get a 1 over 3 minus half. From 0, get nothing. Then plus this one from a 2, get 2 raised by 3, which is a divided by 3, minus 4 divided by 2, which is a 2. Then minus evaluation at 1, get 1/3 minus half. So negative 1/3 minus half. So negative become positive. So get negative 1/3 plus 1/2. Then plus 8 over 3. Then minus 2 minus 1/3 minus become plus half. Right? So now let's see. So with the denominator 3, we have negative 1/3, 3/8, negative 1/3. So 8 minus 1 get a 6. 6 over 3, that's 2. Right? So those 3 terms, combine those 3 terms with a common denominator. So basically we get a 2. Then we have a half. That's 1. Then minus these 2. So we get 1. So the area is 1. We split into 2 regions, right? For A region, we set up integration. For B region, we set up integration. For A region, because it's under or below x-axis, so we put a negative sign up front. So we negate. Let's see this one. We want to find area of A and B. Well, area of B is below x-axis, so we know we need to put negative sign. So from negative 1 to 0, right, the lower limit is negative 1, upper limit is 0 for area A. The integrand is 1 minus e to the 2x, then dx. So this is above x-axis, so we take a positive. Then B region is under axis, so we put a negative sign. So that's from 0 to 1, the same integrand, same function, then dx. Now we integrate. So we integrate. Or maybe you think, oh, right. Okay, we cannot combine those two, right? Because the limits are different. Okay, we anti-differentiate this. So we integrate this first. So 1 integrate 1, that's just 1x. Integrate e to the 2x, we have e to the 2x divided by 2. Remember this 2 divided by 2. Right. So then we evaluate from negative 1 to 0. Then subtract is the same thing, x minus e to the 2x divided by 2. Then we evaluate from 0 to positive 1. So from 0, get nothing. We get a 0 minus x equals negative 1 minus e to the 2 times negative 1, that's negative 2, divided by 2. Then minus at the 1, we just get a 1 minus e to the 2 divided by 2. Right? Then that's first term. Then minus the second term is 0. So 0, x is 0, we don't get anything. So minus, let's put it over here. 0 minus e to the 0, which is 1. 0 minus half. So we have negative, negative become positive, negative, negative become positive. Right, so e raised by negative 2, that's 1 over 2e squared. Can write this way. Then minus, this is a positive 1. So minus 1, minus minus become positive, and plus e squared divided by 2. Then minus minus half becomes plus half. So 1 and negative 1 becomes 0, but we still have a half, right? We have a half here, half here, half here. So we can factor our half. So we get a 1 plus 1 is this one, plus e squared from here, then plus 1 over e squared. We can write this way. So be careful, there's a lot of negative signs, right? When we have a lot of negative signs, we need to be very careful. Okay, this area between one curve and the x-axis. Well, sometimes we want to find area between two curves, like this. So this is below one curve. This is below one curve. So we set up the integration like this. Now we're in between two curves. Okay? So we want to find the area of this weird shape. So what do we do? So the top one we call f of x. The bottom one is g of x. So just subtract them. Why? Because area under g is this much, right? But the area under f is all this. And we want to find a shaded region. And of course, that's f minus g, right? For everywhere, that's f minus g. So that's the only difference. If the top is a curve, bottom is a curve. And here, the first two we have to form with the x-axis. Let's see an example. Let's see, we have this function. We have 2x squared minus 4x plus 6. We have negative x squared plus 2x plus 1. Well, this because, so both are quadratic functions, polynomial degree 2. Positive leading coefficient, so we know that's upward parabola. Negative, right, negative 1, negative leading coefficient, we know that's a downward parabola. So we want to find an area region between those two. So which means those two somewhere, somehow, so they intersect, then they form intersection of the region. So we want to find the area of the region between those two curves. And then we see which one is the top. And this one is f of x, right? It's the top one. Because it's a downward curve. And this one is the g of x. So we need to do f minus g. But this is doing g minus f. Let's see if there's a picture here. Oh, those two do not intersect. Okay. So, okay, so for this chapter, we need to graph the functions first. So let's see the graph first. The graph of the first one with a positive leading coefficient going this way, the blue color, and with a negative leading coefficient that go this way. So they do not intersect, right? So some of them may intersect, right? May have intersection, but those two do not intersect. So we want to find the area in between of those two. And then we use this as a F because this is on top. We use this as G, F minus G. So from 1 to 2, from 1 to 2, 2x squared minus 4x plus 6 minus the bottom one, negative x squared plus 2x plus 1, then dx. So we look for like terms, we combine like terms. We have 2x squared minus negative x squared, that becomes 3x squared. We have negative 4x minus 2x, that becomes negative 6x. We have 6 minus 1, that becomes 5. Then we anti-differentiate, right? We have a 3x cubed divided by 3 minus 6x squared divided by 2 plus 5x. 3 cancel each other, so we have x cubed minus 3x squared plus 5x. Then we want to evaluate at a 2. So we got a 2 raised by 3 minus 3 times 2 squared plus 5 times 2. Then minus everything evaluation at 1. 1 cube is 1. 3 times 1 squared still 3. 5 times 1 still 5. So we get 8 minus 12 plus 10 minus, so the inside, the 6 minus 3, which is 3. Right? So 8, 10, so 18. So positive like terms, minus 15. So we get 3. So the area of this is 3. No units, pure mathematics, no units. Okay, so questions like this, we need to graph first to see which one on top, which one on the bottom. Let's see these two. This one. So that's a graph. So let's see this one. Find the area of the region between x squared and x minus 2 squared from 0 to 3. So we need to graph it, right? So the graph from 0 to 3. So we set up integration from 0 to 3. Then when we graph, we see the area between these two. So the red color is this one, x squared minus 4x plus 4, or just x minus 2 squared. The blue color is x squared. So we need to find the region A and region B, right? Because in region A, we see in region A from 0 to 1. So let's see, let's do one by one. So first we want to find the region A from 0 to 1, right? From 0 to 1, you see this one, from 0 to 1. And which function is on top? The red color. So x squared minus 4x plus 4 on top, minus the blue color, which is x squared on the bottom, dx. So that's 8. Then let's set up for B also. B going from 1 to 3. But the B, you see the blue one on top, the red one on the bottom. So x squared on top, x squared minus 4x plus 4 on the bottom. Then we add those two regions. All right, now let's anti-differentiate. Or let's simplify. So simplify, we see x squared minus x squared becomes 0. So this becomes negative 4x plus 4 dx. We anti-differentiate. Okay? Get negative 4x squared divided by 2 plus 4x. Then we evaluate from 0 to 1. Well, that's negative 2x squared plus 4x. At 0, get nothing. We just get 1, right? Negative 2 plus 4, which is 2. So region A, get the areas to be 2. Let's see B. Let's simplify first. X squared minus x squared is gone, becomes 0. But then we have this negative. Negative, change this negative to be positive. So we have positive 4x. The negative change the positive to be negative, minus 4 dx. We anti-differentiate. Anti-differentiate, we get 2x squared minus 4x. Then we want to integrate. Evaluate at 3. The 2 times 3 squared minus 4 times 3. That's evaluation at 3. The minus evaluation at 1. That's just 2 minus 4. 3 squared is 9. 2 times 9, 18. 18 minus 12. Then minus 2 minus 4, that's negative 2. Negative 2 become plus 2. So we have 18 plus 2, we have 20, or negative 12 plus 2, that's negative 10. 18 minus 10, we get 8. So the area here is 2, the area here is 8, so 2 plus 8. The area in between those two curves, in between those two functions, from 0 to 3 is 10. Okay, let's see this one. So we have x squared minus 2x. We have negative e to the x. We want to evaluate the area from negative 1 to 2. Well, let's see the graph first, because without the graph, we don't know how to set up. Oh, hold on. So this is saying since x squared minus 2x lies above. So, okay, because we have this picture earlier. So then x squared minus 2x set as f, right? Negative e to the x set as g. So minus negative e to the x becomes plus e to the x. Then the rest, then from negative 1 to 2, the rest is just anti-differentiate. So we anti-differentiate, we get x cubed divided by 3 minus x squared, like 2x. Then plus e to the x. Then we're going to evaluate from negative 1 to 2. So from 2, get a divided by 3 minus 4 plus e squared. From 1, negative 1, we minus, or x cubed negative 1 raised by 3, still negative, negative 1/3. Negative 1 squared is positive 1, but we still have this negative sign, still minus 1. Then plus e raised by negative 1. Well, let's see, maybe we can combine some like terms. We have a divided by 3 minus negative 1 over 3. That becomes plus 1/3, right? So a third plus 1/3, that's 9/3. 9 divided by 3, that's 3. 3, then we'll have this minus 4. Then we have this minus 1 becomes plus 1. Then we'll have this e squared. We'll have minus e to the e raised by -1, which is 1 over e. So this just becomes 0. So in the end, we get e squared minus 1 over e. Right? Or maybe we can approximate with some values if we want. But for pure mathematics like this, you leave e squared minus 1 over e, that's perfect. Let's see these two. So we have a linear function 2x plus 4. We have x squared plus 2x plus 3. Looks like, so this one is upward parabola. This is a line. Looks like the first one will be on top, second one on the bottom. We don't have graph. Oh, that's the graph 10 for the previous one. For the previous one, we see x squared minus 2x is above, -1, negative e to the x. So this is for this question. So we have to have the graph, right? Once we have the graph, we see, okay, the line actually on top of the parabola from -1 to 1. So we need to have the graph. Okay, let's see without the graph. So this one, we don't know from where to where. This thing, set up the integral, gives the area bounded by these two. So we don't know where do those two intersect. So what do? We can equal those two to solve the intersection points. X squared plus 2x plus 3 equals to 2x plus 4, right? Because when they intersect, the 2 points have the same value. So that's why we can equal them. So 2x cancel out. Then 4, we move to this side becomes -4. -4 plus 3, that's -1. Then we can factor this, x plus 1, x minus 1. So we get 2x values, -1 and +1. Then we can plug into any one of them. Let's plug into the simpler one. So 2 times -1 plus 4, that's +2. So we get a -1, 2 as 1 point intersection. So that's this one, -1, comma 2. Then when x equals 1, we have 2 times 1 plus 4. That's a 6. So that's a 1, comma 6. So I have these 2 points. So the only important thing for us is the x value, the lower limit, the upper limit, right, on x-axis. So we can set up the integration like this. The lower limit is -1, upper limit is 1. And we see the line is above the quadratic, the parabola. So the line is f of x. The parabola is g of x. So we subtract this. Then we simplify, we get 1 minus x squared. Then we just anti-differentiate to get x minus x cubed divided by 3. We evaluate at these two values. At the 1, we get 1 minus 1/3. Then minus at the -1, we get -1 minus -1/3. So 1 minus 1/3, minus minus become plus, minus minus minus, you see 3 minus 1, 2, 3, that stays to be negative. 1 plus 1, 2, so 2 minus 2/3. So 2 will continue to be 6 over 3. So that's 4 over 3. So questions like this one, we're not given the lower limit, upper limit. We're seeing find the area bounded by the two curves. So we need to find the intersection points by equaling the two functions. So equaling the two functions, then we solve for x value. In this case, x equals -1 and 1. Then we need to find the corresponding y value. Actually, we don't need to. Because all we need is a lower limit and upper limit. Once we have x equals -1 and 1, we know the smaller value is the lower limit, the bigger value is upper limit. Then we set up the integration. Right. Then we anti-differentiate, then we evaluate. Let's see this one. This one, again, set up the integration, gives the area bounded by these two. So we need to do the same thing. We need to equaling those two. So one is upward parabola, one wiggles. Okay, so equals to x cubed minus 3x. So let's move this one to the other side. So get x cubed minus 2x squared minus 3x equals 0. We see x is a common factor of all three. So factor x squared minus 2x minus 3. Then we can factor, so x, we can factor out x minus 3 and x plus 1. Okay. So get three values. Get x equals 0, x equals to -1, and x equals to +3. So those two functions intersect at three places. And we don't know which one is on top, which one is on the bottom. So let's do one without the graphing. All right, without graphing. So what do? We have, so imagine this is the x-axis. So we have 0 here, we have -1 here, we have 3 here. We're going to set up integrals like this. We're going to set up this one from -1 to 0. Then from 0 to 3. Right? Because those intersect at those three places. If the integration in the end is negative, we're going to negate the negative. But for now, we don't care. Right? We don't care which one's on top, which one is on the bottom. So let's just see x cubed minus 3x on top, then minus 2x squared. So let's do this one first. So I have x raised by 4 divided by 4 minus 3x squared divided by 2 minus 2x cubed divided by 3. Then we evaluate. Evaluate at 0, get nothing. 0 minus. Evaluate at -1. -1 raised by 4, +1. So we have +1/4. At the x squared, we get the positive, still get -3/2. X cubed, we get a -1 raised by 3, we get negative, negative become positive. So that's +2/3. So this one becomes, so -1/4, positive. Maybe you'll combine those two first. Well, let's do one by one. So we got -1/4, +3/2, -2/3. Let's keep it for now, because maybe you can cancel with something for the second one. So for the second integration from 0 to 3, but the integration will be the same. We don't have to do it twice. So let's just still use this one. So that's for this dx. Then anti-differentiate, we get x raised by 4 divided by 4 minus 3x squared divided by 2 minus 2x cubed divided by 3. Then we want to evaluate 3 at 0. At 0, get nothing. All we need to evaluate at 3. 3 raised by 4 is 81. 3 squared is 9. 3 times 9, 3 cubed is 27. Then 3 raised by 3, 27. 27 times 2, 54. right? Very big number. So now let's calculate. We need a common denominator, right? So let's multiply by 2, multiply by 2. So these two have the common denominator of 4. And then 27 times 2, that's 54. You can use a calculator. So I have 81 minus 54. I get 7, get 2, so get 27 divided by 4. Then minus 54 divided by 3. All I need is to find if it's positive or negative. So I need to multiply 3 over 3, and multiply 4 over 4. And 54 times 4, 216. 27 times 3, that's 81. So 216 minus 81, that's a 5, 3, 135. So we see this one get a negative 135. So what do? We're going to put an absolute value of it. Okay, we're going to absolute value of this because it's under x-axis. The negative area means under x-axis. So, or we flipped the two functions. So we just get positive divided by 12. So same thing for this, right? Let's see if this is positive or negative. If it's a negative, we just flip. So we get 6 minus 1, that's 5 over 4. Then minus 2 over 3. We see this is a positive, right? This value is positive. So we multiply 3 over 3, multiply 4 over 4. So this one we get 15 minus 8, 7. Right? 7 over 12. Then plus this one. So we get a 142 divided by 12. All right. It's very easy to make a mistake here. But what's important here is this kind of question, if the bounded area bounded by two curves, so we need to find the where do those two graphs intersect? Right? If we cannot graph it, well, if it's for homework, yes, we can graph it. But for exam, we are not able to graph it. So we need to solve, we need to equal the two functions, solve for x value. In this case, x value, we have 3 x values. We have 3 x values. We have x equals 0, x equals -1, x equals 3, -1, 0, 3. So we set up 2 integrals. If the integrals give us a negative value, we just take absolute value of the negative. All right, that's this one. Well, that's the graph. That's the picture. You see, that's why. So from -1 to 0 really depends on which function you put on top, which function you put on the bottom. But if you do get negative, we just take absolute value of the -1. So this we use in live application. Let's see, we have. Let's see this one. A rocket is fired vertically to the air. Its velocity at t is this. Velocity is a linear function. And what do we want to do? We want to find a displacement of the rocket between 0 and A. And then B, we want to find the total distance traveled for this. All right, so for this, I'm going to just follow the textbook. So we need to find the displacement function, which is the integration of the velocity. Right? Integration of velocity. So we need to find S of t. S of t is just S of t, just integration of the v of t. To anti-differentiate v of t. Well, v of t is this. We anti-differentiate, we get this. So that's S of t. Then we evaluate at 0, at A, we subtract them. So we get 256 feet. So this is saying the rocket is at 256 above the initial position, right, after t seconds. So the graph looks like this. Well, let's see B. Okay. You see, A is asking find the displacement of the rocket as t varies in the interval. And B is saying find the total distance. Total distance. So those two are different. Right. From 0 to A, we still have positive, we have negative, because when we integrate from 0 to A, the positive subtract the negative will be offset because the displacement, so it reaches somewhere, right, on the ground. But the total distance traveled, so we need to negate the negative. So we need to graph it. We need to have this graph to see, okay, the area B is under the t-axis. So what do? We need to negate. So we do negative of the value, so it becomes both add. So B, we split from 0 to 5, then 5 to 8. From 0 to 5, we have 400 feet. From 5 to 8, we get negative 144. So we need to negate this. Right, so total, we get positive 544. And here you see we subtract, right? Because the first from 0 to 5 is positive, from 5 to 8 is negative. So the first one, the position, right? The position is 400 minus 144. So I have 256. Okay, this is the difference. The second one is asking for the total, right? The first one is asking for the position. The second one is asking for the total distance traveled. Let's see this one. In 2010, after the online transportation network company launched its mobile app, its client base was expected to grow exponentially, exponential function. A fairly good model for the rate of growth, thousands of clients per year, from 2010 to 2015 was given by this function, this exponential function. 65 times e raised by 0.07 t. In 2015, due to growing computation, this rate of growth was adjusted down and a new model is given. So 79.4 e raised by 0.03 t. We see k value is changed. Also, the initial value is changed. So in both models, t equals 0 corresponds to the initial value, 2010. Estimate the total number of clients that will be lost between 2015 and 2020 due to the computation. So we need to compute both of them, then subtract. So for the first one, so because we start from 2010, right, we're considering 2015 to 2020. So that's why we have this 5. 2015 minus 2010, we get 5. 2020 minus 2010, we get 10. So lower limit is 5, upper limit is 10. So that's for the first one, like R1 of t. Then the second one is the same thing, 5, lower limit is 5, upper limit is 10, but it's R2. Because we want to find the change in between, the difference in between, so we just subtract. Like do R1 of t minus R2 of t. Well, if sometimes we do R2 of t, if we don't have the graph, right? If we have the graph, we graph this too. We see from 5 to 10, from 0 to 5, R2 of t beats R1 of t, right? But from 5 to 10, R1 of t beats R2 of t. That's why we use R1 minus R2. So then so that's R1, this is R2. We anti-differentiate the first one, we just have to divide by 0.07. Anti-differentiate the second one, we just have to divide by 0.03. Then we evaluate, right? That's involved with E. So that's how we use this model in life applications. So there's a difference in between R1 and R2, right? So this is a little shaded area. Area under one curve. Okay, that's 6.4, section 4. So chapter 6 will only go about these 4 sections. So we talk about definite integrals, right? We have this lower limit, we have this upper limit, we have this integrand, and the integrand is capital letter F's derivative. So we use this fundamental theorem of calculus, right? So f of x is the derivative of capital letter F of x. So we anti-differentiate the integrand, then we evaluate the upper limit, we evaluate the lower limit, we subtract. Right? If it's between two curves, we do f of x minus g of x, because in between two curves, right? So I have to subtract dx. If we get a negative value, we just take a positive, we take absolute value of the negative. Okay, we force it to be positive value. If we could graph, it's better to graph it, because sometimes, you know, in like we did x equals to -1, 0, and 3, the two graphs could intersect at different places, a couple of places. Yeah, if we don't have graph, so we get a couple of, so when two graphs intersect, when they intersect, let's see, we have this. You know, we equal the two functions, we solve for x value, right? Let's see, we have this A, we have this B, we have this C, we have this D, right? So let's see, those two functions intersect at 1, 2, 3, make 3 areas. So what do? Because they go up and down, up and down, up and down. We could just make any one. We could use just any one, right? Minus another one. Then we go from A to B, we evaluate. You know, take the absolute value of this. So which means if it's positive, it's positive. If it's negative, we change it to be positive. Then we set up from B to C, we do the same. The integrand will be the difference of those two functions. We take the absolute value. Then we set up from C to D, we do the same thing, F minus G, we take absolute value of that. All right, so that's when we do not have graphs. Okay.